Be live now. All right. Thanks for joining all again to our monthly query research progress update. It's been a bit over 1 month since last time, but that's due to the holiday period. So now we should be back on a regular monthly schedule. So yeah, our high-level goal is still the same. We want to achieve efficient read-write abstractions over decentralized data environments. And for that, we develop algorithms that can hide complexity of reading and writing for application developers. Still the same people working on these topics. Some people are on the holidays. I think Ruben and Yoni won't be here today, but everyone else is. Yes. All right. Format is still the same. So first high-level goal, then accomplishments of the last month, and then targets for next month. All right. And then we can get started with the first person in the queue, and that's Elias.
Yeah, well, it's good to be back. I haven't been at this meeting for 6 months, believe it or not.
6 months.
So I have accomplished quite a few things since I was last presenting in this, at least, monthly meeting. My high-level goal has not changed. It is to develop a framework for storing genomic data in a more efficient way, specifically when we're trying to query it, and enforce privacy policies over that data. Go to the next slide, Ruben. No, you're good. So what I've worked on over the past long while, first is a Solid Cockpit, which is a user-facing application for both interacting with a solid pod and querying data in that pod. This is for a consortium that we are in at the moment, and it will be finishing up at the end of September. So the development is almost done, and then I'm planning on writing a resource paper for ESWC 2026 using this resource. So yeah, that has taken up a lot of my time over the past while. Also, I have a review paper that was rejected initially, and then we resubmitted it to another journal, and now it is currently under review. So fingers crossed on that. There has been a real-world federated query survey that I've been doing over mostly Swiss Institute of Bioinformatics endpoints, and that was a large part of a research stay that I did during the months of March and April, and that is mainly why I've been gone so long. That work is wrapping up. We still have a bit of data to collect and some analysis to do, but we foresee in the next couple months to finish that up and to solidify a target for where we want to present that research. So that's mainly what I have been doing. And then we go to the next slide.
Maybe you can briefly say a few words about some of the findings of this real-world.
Yeah. So the preliminary, we found that there are a lot of challenges when doing federated queries over real-life endpoints, especially when using a query engine like Communica that is very modular and does its querying in different ways. So a recent problem that I've run into is something as silly as like using get versus post for requesting the actual findings of the query. Some endpoints only support get, some support both. So things like that, and running into just a whole bunch of issues and latency problems and just random errors that are somewhat transient. Sometimes the query will work, sometimes it won't. So trying to get this in a presentable format that we can make sense of it has been a challenge, but we're getting there.
Cool.
So then coming up, hopefully I can get this stupid review paper published and I don't have to worry about it anymore. Then final touches on Solid Cockpit, as well as just moving it toward like a production ready state. So integrating some of the UI tests and the unit tests on the actual functionality on the back end. And then writing that paper, that'll be in the next couple months. Yeah, and then in actual research, I will be moving more into defining and implementing a way to convert genomic data in VCF format into semantic representation. And I will be beginning the work on that in the next couple months. Yeah, that's pretty much it.
All right, cool. Thanks, Elias. Any questions for Elias? Yes, Pierre-Antoine.
Yes, thanks for the presentation. I'm curious about solid cockpits. And so you mentioned that it allows users to manage their pod and query the data. What kind of users are we talking about? Are we talking Sparkle savvy users or more a broader category?
Yeah, so we plan on having a large number of example queries that will retrieve somewhat useful things, both within a pod and within a Sparkle sort of query, because it's designed that you can both query stuff that's in your solid pod, as well as query things in public Sparkle endpoints. And then one of the cool things that Brian will talk about is how we implemented a query cache, where you can cache the results from any query that you've done, and then use that cache for either more specific queries that you do in the future, which will, yeah, it's mainly query containment sort of problem. Or if you want to share those results with someone, it also allows for that. So that's more of what we're trying to accomplish with the querying within the pod environment.
Thanks. Very exciting.
Yes, Brian.
I think the other people from Triple Project talked about some sort of Sparkle module thing to facilitate the building of queries. So I was wondering if it's going to be something that you will integrate into Solid Cockpit.
I've thought about it because a lot of what they want to do, from my understanding at SIB, is using the void descriptions of the Sparkle endpoints to build like an autocomplete sort of query building method for like non-expert users, where each step along the process you're kind of given suggestions. And they're also looking at using AI and the LLMs to do this. It's very difficult within my client because solid pods don't have to have that data. And the actual void descriptions and what they give on the various endpoints is the data is different. We're also looking at using.
Sorry.
And they've found these as challenges at SIB as well. So we're going to stick more to just allowing examples or offering examples. And then, yeah, that's kind of the limit of what we're going to move toward.
Okay, I see. Thank you.
It is cool, though. That is a cool thing to explore in the future.
Yeah, because I was wondering if the goal is sort of do some vulgarization, let's call it, if you're going to, sort of append it with other module. But I guess it can be future work of someone else or whatever.
Yeah. It's mostly a time thing. I don't have infinite time.
Yeah.
Maybe one last question before we move over to the next person. What are the main challenges you foresee in the VCF conversion?
Well, I'm just gonna first get a sort of assessment of if it works, just straightforward, convert all of it. If there are limitations to the vocabulary that I have sort of concocted, because it's a combination of multiple vocabularies and ontologies. So first, just seeing if we can represent what we want to in the VCF with these ontologies, and then assessing how computationally challenging it is, how space hungry such a semantic representation is, and then seeing if we can optimize, because I anticipate that it may both require more space than we would like and take a lot of computational time.
And with computational time, you mean computation of the conversion
Yeah.
or also the querying afterwards?
It would, yeah, both.
Yeah.
So it will, yeah, seeing if these assumptions are correct, first of all, and then trying to sort of optimize and reduce some of the complex or the cost in both size and computation.
Yeah. Okay, makes sense.
I have a question.
Yeah.
For the problem of size, would you change the data model, or you would store it, for instance, using stuff like HDT?
Yeah.
Or
Mainly looking at HDT or just virtualization in only maybe converting part of this genomic file when it's necessary,
okay,
and using some sort of index to intelligently determine what part needs to be converted and that kind of thing. And most of that would happen at query time. Potentially.
All right, let's move forward. And I think Brian is next.
Yes. So my high-level goal is still the same, is to optimize link traversal queries using data publication structure. So more concretely, data publisher, they tend to organize their information and also have some metadata, but all of this is really domain specific. And what you want to do is to exploit those structure to be able to optimize link traversal queries, and all of this in the context of decentralized data. So it's not all put into a SPARQL endpoint. Can go to the next slide. So I've worked on three main things this month, I think. So the first one is a query containment solver, at least a prototype for the triple project. So now it's working with set semantic, backsec semantic, and back semantic for conjunctive queries with service clause, and also with value clause. And I've also ran a benchmark over here to make sure of the accuracy that the results are valid. But this benchmark is only for set semantic because, at least as far as we've seen in the literature, query containment for SPARQL only have been done for set semantic. So we're not really able to test it properly for backset and for back semantic, but we're going probably to extend those benchmarks to more properly test it. So the second thing was to make a custom engine of Communica that used a remote cache, and we used two cache hit functions, so two ways to detect if we can reuse those results. So the first one is a simple equality, it's about equality based on the SPARQL algebra level, and the second one is to look if one query is a specialization of another query so that we can reuse those results. But there is some problem that come with that approach, because since it's a specialization, we need to rerun another query over those results. So I need to be able to convert those binding back into a knowledge graph. And also sometimes due to projection, we need to get extra information from those endpoints. So I'll also work on creating those complementary queries and being able to fetch this data from those endpoints. I've also worked on integrated it into Solid Cockpit, but it was mainly the work of Elias, but I've also helped to package everything and so on. And yeah, so those are the two main things that I've worked on for the triple project. I've also worked on the paper. Sadly, my paper on the shape index got rejected by ISWC, but I think it was a pretty close call, and I think it's also the opinion of Ruben Thalmann. So we decided instead to convert it into a journal paper. So I've added also some experiment that I did in the past, some new experiment. I've added some proof and also some clarification because we have a bit more space, and also due to the criticism from the paper, we took the time and effort to add those necessary clarifications. So we can go to the next slide. So for the next month, I'm planning to submit that journal paper. I think it's almost done. I got one review from one of my co-authors, and I've implemented the feedback, and I'm waiting for the review from my other co-authors. I'm also planning to finish this remote caching work inside of Communica, so an early version of the query containment work, and also the implementation inside of Communica. So it should be done at the end of this week or maybe next week maximum. I guess. And I'm also planning to work on trying to formalize linked traversal queries into some form of federated queries to be able to do better query planning. So it's a new line of research for me, or an evolution of what I did with the shape index. And yeah, it concludes my monthly progress. So if there are questions, people can go.
Well, one thing you forgot to mention is the research visit that you're leaving on soon.
Yeah, I'm leaving also Monday to France for a research stay where I'm going to mainly work on my third point, so formalizing this universal queries into federated query.
Yes, and I see Fabien has a question.
Yeah, could you go back to the previous slide, please? Yes, this one. So the remote caching, you say you are converting the bindings into a knowledge graph. What is the idea? Is it something very simple, such as instead of doing a select, you do a construct with the exact content of the where clause, and so you directly have a knowledge graph instead of a binding? Or is it something more fancy? Is it more, wasn't sure I understand what you meant here.
It's something really simple. It's basically we have the bindings from a previous query, and I need to perform a query that is that has more constraint, that is more specialized. But to perform a query, I cannot do a query over bindings. I need to do a query over a knowledge graph. So I'm just taking those bindings and my query, and I convert it back into a knowledge graph.
But sorry again, because so by default the binding is far from a knowledge graph. It's just the list of your variables with the values for each result. So did you develop, because in some engine they have developed an RDF representation of the binding, so it's not really a knowledge graph, but you can load it in the graph. Another way of doing that is taking the basic graph pattern of your where clause and put it in a construct clause, and you create the knowledge, the exact clone of what you were querying, and putting that in your base. So I wasn't sure exactly what you meant by transforming the binding into a knowledge graph.
I mean, it's something similar to the second approach that you said, because yeah, with the variable, my binding are corresponding to the variable of my queries, and in that way, I'm able to recreate the knowledge graph.
All right. Okay.
And are there any restrictions to the types of queries you can apply that on?
Because right now I'm focused on conjective queries, so I don't really have restrictions, but I'm guessing with some property paths, it's going to be a bit more complicated.
Or union.
Yeah, on union also, I think going to be a bit more complicated, but for my current use case, I'm able to do it, and I guess I'll find a solution then.
All right, cool. Pierre-Antoine also has a question, let's see.
Yes, on the same topic. I guess there are two kinds of query containments. In the general case, the specialized query might have additional triple patterns which require you to have the knowledge graph and need to recompute the specialized results. In other cases, the difference might be only in the filters, and in that case, it might be a middle ground which is easier to deal, because then you don't need the knowledge graph. You can make do with only the bindings. Did you consider this?
Yeah, this is what I'm doing. I'm sending complementary queries when I need to have extra informations.
Okay, great, thanks.
Because it's mainly a problem when we have projections that we need those extra triples.
Okay, great. Well, let us move forward to Maarten.
Yes, good morning, everyone. As always, my high-level goal is to optimize decentralized querying using aggregators with incremental processing. In essence, this is the query cache where Brian and Elias are working on. But here the aggregator is a specification to make sure that you actually, that the results are actually being processed somewhere else and not just you do it locally and then you store the results. There's actually a process behind it that keeps the query results fresh. And also it's not limited to querying, but just in general, any transformation of data. So what I've been working on the past 2 months is to actually write a journal on this. And I'm currently working on a proof of concept aggregator and then also a use case, which is a sporting application called Elevate. So the application already existed and I'm just converting the backends to use Solid instead of just a local database. That is done now. So you can actually upload a fit file, which is just a representation of the activity that you get from your GPS or your phone, and you can just put it on your solid pod, and the application gets the data and then calculates all the metrics like average heart rate and stress scores, everything that you want, and puts them back on the pod so you can actually use it on your local machine or another machine if you open the app. The final thing on this thing that I have to do now is, of course, finish the aggregator paper, or the actual finish the paper on this, and also make sure that the connection with the aggregator actually works, because that I haven't done yet, and that's actually the next slide is to, of course, finish the proof of concept aggregator, and of course finish the connection between the Elevate app or the application and then the aggregator, to make sure that actually if you open the application, the Windows the UI actually is much more snappy, because if there are a few, like say 10 or 20 activities, the application becomes sluggish and it needs to load a very long time, and the aggregator will make sure that it loads immediately. And then finally, I made an ontology to actually write all these metrics to the pod. And I want to make sure that the ontology actually a bit more extendable, to add a mapping to DHCC, which is a specification for health ontologies, which should make it more applicable, I guess, or make sure that it's it's a better ontology, let's just say. And that's it for me.
Wait, so that's an existing ontology that you're extending, or what is it exactly?
I made an ontology, but the ontology is a standalone thing. And my promoter actually pointed me to this ontology and said that you can actually extend this ontology to make it more relevant, I guess, because there's a specification to make your own ontology on health activities, I guess. And the ontology, so the DHCC ontology is specifically made to be extendable and to be extendable, so you can make your own properties and so on, and link it to different health properties like heart rate and so on. Then
I have a question. With the proof of concept that you were talking about, you said then that the aggregator is running, and then so then if you open the app, it can look at the aggregator, and so it doesn't need to compute everything from scratch, right? I was wondering whether that means that the aggregator is constantly running, or is there some kind of, or could you also run it in some kind of catch-up mechanism where you say, okay, the aggregator has computed everything since last that I opened the app, for example, and then if you open the app, it just catches up whatever is new. Does something like that exist, or just only?
So with Incremunica, so the incremental query engine that I built, you actually have deferred evaluation, where you can actually tell Incremunica to do nothing until you tell it to recalculate or catch up, I guess, and refresh the query results. And this is actually the thing that you can use, that when you ask for the query results, you can actually use this deferred evaluation to catch up in the aggregator, so you get fresh results and give that back to the user, which would only take like a few milliseconds to actually process the last few things, unless there is like a bunch of new stuff, but that shouldn't be the case in most cases.
Cool.
So yes, this is possible.
Okay, cool. Thank you.
Thank you for the question.
Okay, any other questions for Maarten? So once your journal is done, do you have any further plans on Incremental?
In Communica, not immediately. There are plans to actually. So I asked for a LBIT funding to actually convert Oxygraph into an incremental query engine, but that's still up in the air. So yeah, I'm not sure if that's gonna be happening, but I'll know by mid-October normally.
Okay. Fingers crossed.
Fingers crossed indeed.
Okay, I think we can then move over to Jitse.
Yes, so for me, it's also been, I think, 4 months, and I didn't really look at the slide. So my high-level goal is to optimize write performance in decentralized personal data ecosystems, although I haven't really looked at that a lot. My high-level goal is to look at, currently I'm focusing at interfaces level. So we have this decentralized data ecosystem. So it's a data ecosystem where there's multiple nodes and they don't really work together. And now we want to have a query engine that works in a federated or a decentralized manner over these data stores. And so then the problem that I'm currently looking at is how these interfaces can kind of communicate what data the data stores store, and how to interact with them properly, and more about that later. So what I worked on, first I attended ESWC, where I had a demo and a symposium, a PhD symposium, and then I also attended ISWS, so that's the summer school. I enabled the poster award there. So that's nice, because the ideas I presented there in a poster, the ideas of these interfaces and how that they should communicate what data is exposed, which is also something that I talked about in the second accepted paper here. So that's the interface data description paper that I submitted to Hyper Agents workshop at ECAI, the European Conference for Artificial Intelligence. So that's nice, because I don't have the words for it's good. Yeah, it's nice. So then also the paper, I also got a paper accepted for the semantics work, the SEMDEF workshop at Semantics, which is next week, where I will present a modular parser approach. So an approach for building a modular parser where you have grammar rules and kind of patch in your programming, in TypeScript, because the parser is written in TypeScript currently, but then within TypeScript you can kind of modify the parser to patch a grammar rule or add new grammar rules or delete grammar rules, and these things. So I'll present that there, and then
that the motivation of that one is essentially to make sure that we can easily keep up to date with the evolving Sparkle versions.
Yeah, so the idea for the modular parser is indeed to easily kind of have these various versions in Sparkle. So the idea is that after Sparkle 1.2, more new Sparkle versions would come rapidly. And then the idea is also to be involved in the kind of decision making, I guess, through Ruben, since you are also involved in these specification. So we can easily test also new language components and yeah, provide feedback on top of that. So for this, we need this modular parser that can make us easily play with these things, which is also not the right word, but it suffices. So then so attending ISWS, we worked in a group of people where we need to write a paper, and our supervisor there said that this was quite a good paper and that we could submit it to a workshop. So then we patched it up a little bit and submitted it to the XI-KRKG workshop also at ASI, and it also got accepted, but I don't know if I will be presenting that. Maybe someone else of our group will do that. So that's that. Then I've prepared for some logistics for my research stay at the Technical University of Vienna. That starts in September. And then I looked at the round-tripping in Dracula, which is this modular parser from before. So where we wanted to have, if you go from a Sparkle query to an abstract syntax tree, that we then also want to go back from that abstract syntax tree to the exact Sparkle version, to the exact Sparkle query that we started from. And the idea there is to have some kind of linter rules or query rewritings, while not just completely destroying whatever format you had for your query. And then I also integrated Sparkle algebra in that, so that from the ESD that Sparkle that Dracula creates, you can also go to Sparkle algebra. Yes, so that's that.
The research stays 2 months, right?
The research stays 2.5 months.
Okay.
Yeah. Okay, so that's that. Next targets. So I talked about this this interface data description paper. So there I kind of try to motivate why we need to embrace the asymmetry in interfaces. So where you can, for example, have resources, but the operations that you perform on the resources aren't exactly like deleting triples or adding triples, that there's also need for other operations. And this is this asymmetry, but we need to fundamentally understand why that is needed. Then I also have this demo next week. So currently hard at work for that. And then working at the Technical University of Vienna on query rewriting between Sparkle versions and similar languages. So this is looking at whether we can make some kind of transformation between Sparkle 1.1 and 1.2, and maybe similar graph-based languages like CQL, I think, was mentioned as well. Yes, and I need to. It's only recently trying cycling through my head that I'm actually doing this research thing. So I haven't really looked at it too much. But this week I realized that this is next week. So I will also start looking at that.
But you have your stay already.
Yes, I have my stay, and I did the work that needed to be done in order to do it. But then the actual not being in Belgium for 3 months, that is slowly cycling through.
It will be nice there.
Yeah. Okay, that's it.
All right. Any questions for Jitse? Yes, Brian.
Yes, I have 2 questions. The first one is, when you talk about patching new rules inside of your algebra, is it a completely new concept, or is really specific to Sparkle, or does it already exist for other languages or other fields? Is it something that is well studied, that is sort of adapted to Sparkle?
I didn't really look at that. This is also a feedback on the paper, whether this exists for other languages.
Okay.
So yeah, I'm sorry. But generally speaking, from what we saw in the literature for Sparkle, is that most query length, most query engines create their parser through some kind of parser generator, and then there it's quite hard to make it modular because you are within this file, and either you need to completely copy the EBNF file, so they use their own syntax kind of to generate the parser, and then you need to copy the parser and kind of toy around in that new thing, or have kind of inheritance where you say, okay, I have this parser, and now I add some new rule, but then it's hard to kind of fit a rule in the middle of that parser because then you would break the inheritance tree, which Dracula would also allow.
Okay, and I guess you need also to detect if you introduce some sort of inconsistency or some sort of ambiguity.
Yes, so for this, Dracula relies on Chevrolet, which is a library created by someone else that works really well, and they tried to they kind of optimize these grammar rules and try to detect inconsistencies. But like type inconsistencies aren't. Well, some inconsistencies aren't detected because you pass around the AST within your grammar rules, and if you don't properly patch your types, then properly patch your rules, then there might still be inconsistency. So, for example, if this grammar rule expects a number to come out of some other grammar rule, and then all of a sudden a string comes out, then it will still perform number operations, even though now it's a string. So then you should also kind of know that you should patch that rule that depends,
Okay, so it cannot be fully automatic inside of this framework.
No, you still need to kind of understand what is happening. So for that, it's important that these grammar rules first are shared properly, because you need to have access to the grammar rule itself, as in export it in your package. And then you can also see that look at the types, and then a lot of it will also come to once you have built your parser, that you can then also generate some kind of nice summary of what the parser actually does.
Okay. And with this summary, then you can validate it basically more.
Yeah, but then it's also a manual process of validating that.
I mean, you can automate it, right? If you have it into a formal way, you could give it to a solver, make sure that it's
maybe.
Okay.
But that's not that's not in scope or something. Yeah.
Okay. And my second question is that I really didn't understood what the asymmetry mean.
Yeah, it's a bad word, I think. I don't know if it I don't know how to easily explain it yet. So that's why I need to more fundamentally understand it so that I can more easily explain it.
So,
but it's in that
for next month.
Yes, that's for next month.
Stay tuned.
We gave a general idea or something.
Yeah, so currently you have like the CRUD operations are like you take a triple, you delete them, or you add the triple, like with a modified Sparkle query, you say I delete the triple and I add a triple, or I have some kind of bindings and then I but this so mostly interfaces are like delete these triples or add these triples. But maybe you want to have some kind of operation that says take these triples and modify them in another way. But that's
speaking. What do you mean?
So interfaces have different granularities, and like one that allows you to do the most, right, is like a Sparkle endpoint where I can just say modify the underlying data in specifically this way. But then if you go to, for example, more of a RESTful interface where you say I have this get operation or this put operation to some kind of document, then it's also always translated to changing some underlying, almost always translated to changing some underlying database. But it's not really explained how that underlying database is modified within that certain operation. So if I have an operation that says that I want to change my name, then often what you will have is a documentation that says in human readable language, mostly English, this calling this operation will change your name. But then, yeah, it's not like a query engine knows like, if you perform this operation, then the underlying database will change in this manner. So it's hard to kind of reason what a combination of operations actually does, because it's always you need a man, you need a human to understand like what these operations are doing.
Okay. So it's some sort of creating a unified language for those operations that you do over those endpoints, so that you would be able to describe.
We're looking within the hyperations paper. We look at Sparkle to describe these operations.
Okay, so using Sparkle as a universal language for any sort of API call.
Yes.
Well, the open question is still if Sparkle will be sufficient.
Okay.
My feeling is that it's not, that we'll need something more high level, but we'll see that later.
Yes.
Okay, but I think now I understand better the overall what it means basically.
Yeah.
Thank you.
All right. I see Fabien also has a question.
Yeah, so I'm involved in the hyperagent workshop. So I looked at the I looked at the reviews on your paper. One of the reviewer, if I'm not mistaken, he pointed two things: the need to formally define the asymmetric, so what you actually just discussed, and also the fact that your paper focused on checks, but in fact could be done with, if I remember well, ask Sparkle query.
Yeah.
And so I wonder if you were able to address that in your final version. I didn't check, I must admit, your final version. So
I have not addressed this. I did write it down because it was an interesting comment, because I didn't really think about ask when I wrote the paper, but I think it's certainly interesting to investigate ask as a way to kind of describe these shapes. Yes.
And I also think it's important to take the time to because it was kind of an important point in your paper. The asymmetry needs to be explicitly defined in some way.
Yeah.
No further comment on my side.
All right. Then I think we had everyone. So thanks all for joining today. So our next meeting will be on September 30, if I'm correct, again at 9:30. The group will probably be slightly smaller because Brian and Jitse won't be here. They will be on a visit, unless you want to join remotely, but that's not required. But yeah, some other people will be back from holidays, so the group size might actually be exactly the same as now. I see Pierre-Antoine also has his hand raised at the moment.
A small question to you, Ruben. During the summer, we discussed about a possible extension of Communica to support RDFJS datasets versus stores, or was it the opposite? I was just curious if you have any progress on this.
Yeah, indeed. So there was a job student working on this, and it's implemented already. It's just not released yet, but it's implemented in the master bench. So yeah, he's still working on some other things. So once his contract ends, I'm planning to make a new release of Communica, which will contain many useful new features, including that one.
Yeah, that's great. Thank you.
All right. If no other final last comments, yes, Brian.
I think I have a clarification about the question that I think Fabien asked me about the conversion of bindings into a knowledge graph. I don't think that the unions will really be a problem. I really think that the repeated property path, like with the claim star and the plus, I think there will be a problem because we don't know how many times they are repeated. So this conversion will really be dependent on the subqueries. Whereas with the union, I think I can find in which branch a specific binding will be located in. So I think I would be able to, quote unquote, relatively easily to convert it into knowledge graph. But the property path will really necessitate big changes into the way that I do this conversion.
Yes, I agree with you that union and optional are going to be much simpler because if you take the semantic of a construct, you could actually have the conjunctive basic graph pattern of what you had in the union directly in there because it would only instantiate the one that are binded. So you would create the knowledge graph of whatever branch of the union was selected. So it's going to be much simpler than the property graph because the property graph, you are going to miss the intermediate nodes. I think is that your point?
Yeah, that's my point. And I think that's the thing that's going to be more hard.
Yeah, I agree. It's going to be tougher.
Okay, then I guess we're done for today. So thank you all for joining and thanks for the interesting discussions and see you all again next time on September 30.
Okay.
See you all.